Hey everyone, you're listening to the Simple Electronics Podcast. I'm your host, Dan, from the Simple Electronics YouTube channel, and this episode is brought to you by PCBWay. More about them a little bit later on. So let me just get a couple things out of the way. This is a very different episode of the Simple Electronics Podcast, and it is different in the sense that it could really have been filmed live. So this is the first time ever that I'm recording this on the Thursday that it is supposed to release on YouTube. I got a little bit behind because I prioritized some other stuff and I also procrastinated way too much. And so it got to the point where I was recording way too late at night. I was way too exhausted on the day that I normally do these, which is the Wednesday before it goes live or the Tuesday sometimes. And it got to the point where I just needed to go to bed. So this is recorded on the very same day that is being released on YouTube. Another thing to get out of the way is the subject of my voice. You may have heard it just break up there, but my voice is getting way better. Now, what did I do to solve this voice issue? Absolutely nothing. I procrastinated going to the medical center, to the walk-in clinic, I should say, because here in Ontario, it's kind of a pain in the butt. It's a, all-day affair type thing. And so I really didn't want to go. And plus, my voice was showing signs of getting better. So I decided not to go. And then it got worse. And then when I was planning on going again, it got better. So right now it's on a better stage. In fact, it is so much better that I've been live streaming again. So I would really love to catch you guys on the live streams. That is youtube.com/@SEstreams, SESTREAMS, all together like that. There's a little bit of a crowd forming now. There's kind of like a group of regulars who are coming in to watch the live streams. And it's really a great way to get a behind the scenes look of what it really takes to record YouTube videos, especially when you are someone like me who's just learning as they go. I'll give you a couple of poignant examples of this week. Today, I was working on a USB PD decoy board. So essentially, this is a board that you plug USB-C in, and you plug the other end of your USB-C cable into a charger. And then there's a couple of buttons on this charger, and those buttons request different voltages. And so I was struggling with that thing for nigh on 4 hours because the USB PD functionality, the USB PD protocol functionality, is very simple. You just press I think it's a red button, and it cycles through the voltages. And then if you want to go into PPS mode, which is a USB PD power supply mode, the device is less useful. So you would long press there's a red and a green button. So you long press the red button, and then you can tap the green button to increment up the voltage. But the voltage only increments in like 20 milliamp chunks. So that wasn't too bad. It's not a great module for using as power supply, but at least it remembers where it was when you unplug and plug. So you only have to set it once. What was very difficult on this module is that there are examples, or there's instructions, I should say, on how to get the quick charge protocol, not the PD, but the quick charge, the older standard, to work. And I couldn't for the life of me get it to work. And at some point, I had to try to figure out whether the device I got was faulty, whether the instructions had a typo in it, or whether my equipment was just not quick charge compatible. So that literally took all morning to figure out. So these are the kinds of things where you come by and you hang out and you get to see the results of it, a week or two down the line when the footage gets edited into a full-fledged video. It is not the greatest viewing experience, however, because I am filming still from my overhead camera, and the live stream is watching, slightly to the right and slightly up from that. So it's not quite the same view as what you get on YouTube. It really is like a behind the scenes view. So I encourage you all to come and take a look at the live streams, and that is youtube.com/SEStreams, at SE Streams. The at is very important because the channel was made after the migration to the at usernames. Anyways, for today, I would like to take a look at a couple of projects that I found on Hackaday and sort of like chat through how the projects are made, what I think is cool about them, and why I think they're relevant to my channel and my audience. So let's get started with that. So the first project on the list, and by the way, all the projects will be linked in the description below if you want to go take a look at the details, is actually one from 2014, which is really odd because it was in the kind of like featured list on Hackaday, where this is from Adam Fabio, and he made an analog CPU gauge. So essentially, when you are performing tasks on your computer's processor is being used more or less. And there's like a API or there's open source software that you can interface with that. You can actually go and detect what's your percentage of utilization on your processor. And so Adam did this. He used this open source software to come out to an Arduino. It doesn't specify what kind of Arduino he was using. If you look at the components, it's 8 flyback diodes and 1 times Arduino. Not sure what kind of Arduino, but I guess in 2014, there was not all that much stuff going on in the Arduino world. But out from the Arduino, then is probably a motor driver. It doesn't specify. But then that goes to a stepper motor. And this stepper motor is a SWITEC, SWITEC, and model is X27.168. So apparently, this SWITEC stepper motor is specifically meant to replace the gauge dials on some, a whole huge number of different vehicles. These vehicles, I don't know which ones, they're not specified. I could actually do a quick search for that. It looks like it's mostly GM stuff on my quick look. But apparently these gauge clusters would get damaged. These stepper motors would stop working. And the manufacturer wanted to sell the vehicle owners a complete gauge cluster, a whole unit. So they developed this aftermarket company, SWITEC, developed this replacement that you can just desolder off the original gauge cluster and solder a brand new one in. However, they got mass marketed, and then you could just buy them just like that for really inexpensive. And so this gentleman, Adam, he decided to use one of those. He created a custom PCB. He did it in DipTrace, I believe. Custom PCB to accept the stepper motor and then have pins to go out to the Arduino and very likely, I'm guessing, a motor driver. Not very many details. And then he 3D printed a needle and he 2D printed, like out of a printer, a gauge face, and then programmed his Arduino to respond to read the amount of load on the CPU in his computer. And this thing would output a percentage, based on the stepper motor. And I think that's really cool. I always like analog type gauges for stuff like that, somewhere that you don't expect it to be. I remember back in the Windows, I don't know if it was 7 or XP, I think it was 7, where you can have gadgets that you put on the background of your computer. And one of those gadgets you can put on was a CPU usage meter, and it looked like a car gauge, right? And you can just stuff that on your background and it would let you know your CPU's performance. It probably robbed a little bit of performance in order to power the gauge, but either way, you can have it there. And so this is kind of like a physical sort of determination, a physical version of that. So I think it'd be pretty cool to, when I export my videos, if I had a CPU and a GPU usage gauge to see how hard the computer is working, right? That would be really interesting. even more interesting than that is somewhere in my workshop. I don't know if some of you have been watching the channel for long enough to know this, but I took apart the gauge cluster on, I think it was from like a 2017 Honda Civic. And that gauge cluster, I took it apart and I found some of those stepper motors in there. Maybe they're not the exact same ones, the SweeTech ones, but definitely they're on the PCB. And so maybe I'll have a poke around on one of my live streams. And if I can find that PCB again, then maybe we can salvage those stepper motors and see if we can create a project similar to Adam's. I think that'd be really cool. However, if I was starting from scratch, like if someone asked me to build this project for them today, I think I would use the really inexpensive stepper motors. I don't know if you know the ones I'm talking about, but they're geared. Not the powerful ones for a 3D printer. I'm just doing a quick search as we speak here. They're called 28BYJ48, and they come with usually an ULN 2003 driver board. So I'm looking here on AliExpress, and I can get 5 for $13.68 Canadian. So I don't know, roughly something like, $9 or $10 US. So about $2 US each for the stepper motor and the ULN driver. And the reason why I would go with that is because the ULN driver already has the flyback diodes and stuff, the circuitry, and the Arduino just has to send out the pulses and control the stepper motor like that. The only thing with these stepper motors is they're not because they're geared and they're geared kind of loosely, the gears kind of sit loose in the housing. They don't really have as smooth a motion. Like the automotive gauges have a very analog, very smooth motion. So it may not be exactly the same, but I think it'd be pretty close. The other advantage that the automotive gauges have on top of that is that the needle, like the shaft of the automotive gauge, is so small. It's literally like the size of a pencil lead. And so you have more flexibility in your needle design, I guess, that you would go on there and put in. But really cool. And I think actually, if you could get an automotive one and you get some, like you go to the scrapyard and you get an automotive gauge cluster, it'll come with a dial, it'll come with the needle, and at the same time, there's probably a position behind the needle where an LED sits on the board, and when those LEDs light, the needle is actually like a light pipe, and you can light up the needle at night. So maybe there are advantages to automotive things. But let me know if you had to make an analog gauge and have it be as smooth as possible, what technique would you build? Would you build, something with an automotive part? Would you repurpose it? Would you get a ULN 2003 and a 28BYJ48 stepper motor? Or would you just go all out and just use like a NEMA 17 stepper motor? Let me know. The next project up is a doozy. It is by Nick Bild, B-I-L-D, and it is for people who love audiobooks but don't necessarily have access to them. So let me paint you a word picture here. So it is a aluminum frame, looks like an aluminum frame. So like an aluminum square that sits flat on your table, and there's a boom that goes vertical, and on that boom is a Raspberry Pi Zero 2W and a USB webcam. So it runs a Python script, waits for a button press, then takes a picture of the book with the webcam. The picture is uploaded to Google Gemini, along with a prompt telling it to take all the text out of the page. And then the text it returns is sent to Piper to synthesize a speech, and then it is played on a Bluetooth speaker. So essentially, it takes a photo of the page, sends it to Gemini. Gemini extracts all the words. The words are sent back to the Pi that locally synthesize the speech, and it plays on a speaker. absolutely insane in the best way possible. This is crazy. So I've seen these kinds of rigs before where there's like a frame and a camera suspended on top. And essentially you make your own ebooks by taking a photo of each set of 2 pages, and then you flip the page and then photo and then whatever. And then you put all the images into software, and that software will convert everything into a PDF and properly crop everything and go over with OCR and etc. This is like pushing it to the next level. I mean, I do have a Pi 02. I think I have a Pi 02. Either way, I have a Pi 1W. But you can use any Pi for this, and I have a couple of Raspberry Pi cameras. So essentially, this could be something I do. I personally don't think that I would want to send a whole page of text out to Gemini to extract the text. But perhaps if you use a regular Raspberry Pi instead of the Pi 0, you can run that software that runs your image, converts your image into a PDF and then runs an OCR over it. And then you can extract the text like that. I mean, that's possible, right? But this is the kind of thing where this person, Nick, I presume, probably, thought of this and thought whether or not he could and not whether or not he should, because I'm sure there's a video that accompanies it, and I recommend you go to the links in the description and take a look at the project to give Hackaday a little bit of traffic and the individual creators some traffic too. So Nick included a video, and it's interesting how much time it takes for the image to get taken, sent to Gemini, text return, and then synthesized into speech. I'm sure he can read a lot faster. But you know what? Us enthusiasts, hobbyists, we don't necessarily do things because they're practical. We do things because we can. And this is the perfect example of this. And I mean, if you look at my situation, I've got a Pi doing nothing, and I've got Pi cameras doing nothing, and I've got aluminum extrusion doing nothing. And even if I didn't, I could just lower the bed on one of my 3D printers or raise the gantry and put the camera there, right? These are all things that you could potentially have and toy around with and just have fun. You don't really need to have a point to it. So he calls this project the Page Parrot, and I think that's hilarious. I think it would be cool to see if you optimized it, if you threw a little bit more horsepower at it, like maybe even use the USB webcam and a mini PC, how fast it could synthesize that speech. And if potentially you could just snap the shot, turn the page, snap the shot, turn the page, and keep doing that. And then the words would just keep streaming out into one big file. I think that would be really cool. Actually, on that subject that I have Pis laying around doing nothing, I went through my old mailbag queue because I stopped making mailbag videos quite a while ago. I just gotten a lot of negative comments, and they were kind of right, saying, why am I subscribed to this channel? It's all mailbags, because mailbags were the easiest videos for me to make. So anyways, I went through on the live stream and cleared out the mailbag queue. And one of the things that were in the mailbag queue were a MakerBase Pi, like a fake Pi. It's based on a rock chip, but apparently it is pretty much like a Pi clone. You can run the Pi software on it. The point of it was because Raspberry Pis were getting kind of scarce and expensive, and people loved Raspberry Pis to either run Clipper or Octoprint on their 3D printers. And so a third-party company stepped up and made a clone Pi that you can use for those kinds of things. So I wonder if this clone Pi is more powerful than a Pi 0W. Interesting thought. All right, you're going to have to strap in for this next one. This one is just by a person called Christian, assuming it is a man, just by vibes alone. This is a clock, but what's so special about this clock? Well, let me tell you the title. It's the electromechanical analog digital clock. So yeah, it is a clock. And I think the big thing that will set this apart is that it doesn't use a crystal for its time source. And this being an electronics channel, it also does not use a 555 timer for its clock source. It uses a 50 hertz AC source that runs a 200 stepper motor. And the way that it is 200 step per rotation, I assume, and the way that it is set up with dropper capacitors and the transformer feeding the stepper motor, it does one full revolution every second. Okay, so it takes that, and the revolution of this stepper motor is the clock source. That is really cool. And then there is a light detection circuit, and there's an arm on that stepper motor that breaks the light beam on that detector circuit, and it feeds into a CD4040 12-bit counter. So this thing is counting up to 60 like all the time, basically. It is so cool. Then it takes that digital signal, turns it into an analog using a DAC 0808, using the default circuit from the data sheet, and then that sends out a analog waveform or an analog voltage, which then feeds into moving coil instruments, so analog gauges, that has a modified gauge face from Corel Draw, and also it has modified circuitry, so it works between 0 and 5 volts, and then therefore you've got two gauges, one displaying minutes and the other one displaying hours. This is incredible. Like, just the thing sitting on the desk. You guys really need to go check out the gallery. So yeah, there's minutes and hours on two gauges side by side. Then you see a stepper motor whirring away, and then there is the counter circuitry and the ADC circuitry, and there's display LEDs. It is probably the least practical clock you will ever see, but one of the most interesting clocks you'll ever see. I mean, there are tons of cool clock projects, but this is definitely one of them. And just the name basically tells you, what to expect. The electromechanical analog digital clock. Super cool. Uses discrete components. It looks like he made custom PCBs. Let's see. Where did he talk about? Yeah, it looks like there's a project here. What is he using? I can't really see what he's using. Oh, maybe it looks like EasyEDA, something like that, to design. He's got images of everything. He's got the circuit diagrams. Just awesome. Like, why not do it because you can? So he's got PCBs made. PCBs are stacked on, with brass standoffs. The thing is incredible. And it's got, apparently the stepper motor whines loudly at 50 hertz. So you can just imagine what that sounds like. And he also has that stepper motor is suspended between four springs in a brass sort of cage in order to quiet it down. Incredible workmanship. That is just, it just tickles me just the right way. This is from 2020. So CMOS logic, moving coil meters, stepper motor for the clock source. Who would have ever thought of that, right? Using the 50 hertz as a clock source. I guess here in North America, since we have nearly exactly 60 hertz AC waveform, this person's in Germany, so they have 240 volts, 50 hertz. But to use a 50 hertz source to move a stepper motor, which breaks a light beam, incredible. Absolutely incredible. And even better than all this, it's all documented. The whole project is documented. He like writes down how he figured out the proper capacitors to use, the impedance of his stepper motor. It's incredible. He went through all of this stuff, even like the part numbers, like the light barrier that he used is an ITR 8102. This is like next level nerdery. He even has images of the circuit working with the analog meters on breadboard. So he built this all on breadboard and then moved it all to PCB. Absolutely incredible. I can't believe it. I need to reach out and see if he wants to talk about this project. That is awesome. In fact, I'm going to click his name and see if he shows up on any other Hackaday articles. Oh boy. Yes, he does. He's got, maybe I have to reach out to him. Anybody know? Let's see. Share the profile. I have to figure out how to reach out to this person because this work is incredible, and I really hope you guys go check it out too.
Just a quick interruption to talk about this episode's sponsor, PCBWay. PCBWay has been a long-term sponsor of the channel, and I think they're a good match for my channel because they provide quality PCBs for a reasonable price. You can get boards manufactured up to 100 mils by 100 mils for just $5, including shipping to Canada, $15 US, including shipping to USA, $12 US, which is incredibly cheap for professionally manufactured PCBs. I can personally attest to the quality of these PCBs, and so if you want a circuit immortalized forever, check out PCBWay.com with the link in the description. Now back to the conversation.
A little bit of movie magic here. I actually paused the recording of this podcast in order to reach out to the creator of that clock, Christian. And I'll tell you, signing up for Hackaday was a little bit of a pain in the butt. But I did send a DM to him. I hope you guys go check out his project, but I'm really hoping, I'm crossing my fingers that perhaps he'll want to come onto the podcast and chat about his various projects. He's got a whole bunch more in his profile, so check that out. All right, going from a little bit crazy in the best way possible to something very artistic in a very different way. So we've got the hexagon LED table that is from Nicholas Bertrand. So it's the pitch is it's a table made with epoxy, 98 hexagons shape, and 427 RGB LEDs. So this is essentially it's a table, but Nicholas went through the painstaking trek of making a whole bunch of hexagons, so 98 hexagons, and each of them are individual. So they don't share any sides. So if you go 98 and multiply that by 6 sides, that's 588. So he cut 588 beveled pieces of wood to make hexagons to lay down in a pattern on a table, in a kind of like a honeycomb pattern. So if you can think one hexagon in the middle and then 6 equidistant hexagons around that. And then, whatever the next layer, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12, outside of that, and so on, expanding patterns, all sitting on a coffee table. I think it's a coffee table. And then arranged in that grid and then dropped into a frame, that frame filled with epoxy, and then underneath that epoxy, it's all neopixel strip, and he's using a BeagleBone black to control the neopixels. And so tabletop was all polished and stuff, and the LEDs shine through. I mean, the epoxy is like a milky white, so it's like really nicely diffused lights, but the outside, like the surrounds of the hexagons, have LEDs, but also the insides of the hexagons have LEDs. And so it makes patterns with not only the hexagons themselves, but the outsides as well. And having patterns that contrast the inside and the outside make it look really pretty. The only thing that bothers me a little bit, because, no hate to Nicholas, it's a fantastic job. It looks really good, but it uses 9 kilograms of epoxy. And for, let's see, 9 times 2.2, that is almost 20 pounds of epoxy. That is a lot of epoxy. I don't know how much that would cost in Canada, probably a couple $100 for some good quality stuff. And then you have to mix tint into it to get the right, color that you want. And I don't even know if you can pour that much epoxy in one shot. It looks like you did it in 3 pours, which that's good, because that is crazy. I don't know if you know this, but epoxy is an exothermic reaction. And so when you react the catalyst with the resin with the hardener, it combines and it releases heat. And the hotter epoxy gets, the quicker it cures. And so if you mix too much epoxy, what can happen is the reaction starts to kick. It generates heat. That heat makes the epoxy cure faster, which generates more heat because it's now kicking more. And then it sort of like cascades and avalanches into like melting stuff, catching on fire. All sorts of bad stuff can happen. And because the source of heat is internal, it's actually the curing process, it is a very difficult thing to stop once it gets going. So usually if you have that happen, most of the times it happens like in the garbage can. For example, like the rest of your pot that you didn't use, the rest of the epoxy you didn't use, you throw it in the garbage can. That pot gets very hot, and then it starts to burn the things around it. The things around it starts to catch fire. So then your garbage can catches fire, which then catches, your wooden desk on fire, and et cetera, et cetera. So it looks like you did it in 3 pours. First one, 2 millimeters. So you get a 2 millimeters without any shapes on it at all. And then the wood gets put on top of that, and then filled 17 millimeters, and then create the border, and then after that, the rest of it. So that's pretty cool. The beagle bone is driven with, and it has 5 power outputs with regulators that can each give 3 amps, ESP32 controller, 5 outputs in neopixels. So I guess there's 5 separate channels of neopixels. Really cool stuff. When was this made? Let me just look for a date here. I don't see a date. Let me check the comments. The comments were, a day ago. Okay, so this is very recent. So that's cool. So they might be using something like WLED in order to make it work. They have some design files. Nope, they have a video file. Yeah, I'm not going to download that. And in the discussion, people are just saying on how awesome it looks. And it does. It truly does look phenomenal. I think this is one of those things that, 9 kilograms is a lot of epoxy, but this is the type of furniture that you'll probably have for the rest of your life, right? Especially if you know how to work the epoxy. That means you can fix the epoxy if ever it were to get damaged. Really cool stuff. The last project we're going to talk about is called Pocket PD by Sentilab. Now, this is something you can probably have heard about. I know Great Scott has made a video on this, and I'm in fact working on a video on, the protocol. I'm not doing a video on specifically this, but Pocket PD is a USB-C portable benchtop power supply. So essentially it uses the PPS protocol of USB PD, what I was talking about in the beginning, those little modules that you can program, however many volts you want from your USB PD power supply. As long as I think it's PD 3.1. There's also a 3.2 version. So as long as your charger can do PPS over PD 3.1, it'll be compatible. But essentially, it's just a single USB-C cable and a single charger that you plug into the wall, or even it can be a large power bank as well. And this device, you can get a dongle like I have that will give you any voltage. The only thing is it's really clunky to use. So what people do, like Sentilab here did with this Pocket PD, is they make a better interface to interface with those PPS compatible PD chargers. And so what they've done is they've made a power supply that is tiny, absolutely tiny. It has banana plugs and a USB-C rotary knob, a couple of switches, and that is it. It's just about that size. Like, there's room for 2 banana plugs, a XT60 connector, and a couple of terminals, and a USB-C, and a small OLED. And you just turn the knob in order to get the voltage you require. And so this means that combined with sort of like a gallium nitride, like a GaN charger, like you see on Amazon all the time now, companies like Anker and Ugreen and all sorts of other companies make them. That means you get a power supply that literally fits in your pocket, that is adjustable, I believe, down to 20 millivolts. So you have 20 millivolts of actual adjustability. Really cool. So let me read a little bit about what they're saying here. So I'm not sure if this is open source, but what their big claim to fame is that there's no buck or boost converter inside the board, because it just talks to your USB charger. So it's literally an extension of your USB charger, and that's how it becomes so small. And they are looking to implement constant voltage and constant current modes, which I should be able to just be done with feedback, which is pretty nice. So essentially, they have open source the software. That's their goal after the development is done. And I'm not sure if they're going to open source the hardware. I would really love to see them open source the hardware, but I mean, it's really not, it's not my place to say, right? I'm not the one building this. So at the moment, you can buy the board from Lectrons or Tindy. Let me check how much it would cost from Tindy, because there's not a lot. Yeah, $65. Not a lot of componentry on it. This is a really interesting thing because there are actual chips that handle this communication back and forth with the charger. And in fact, the decoy dongle that I bought from AliExpress in order to interface with those chargers has one of those chips. But the problem is the implementation, right? A lot of these chips use button presses in order to communicate, like essentially they're set up to use a button. But some of these chips that I saw in my research, because I had trouble, getting it to work. So I set out to do some research. Some of these chips just use an I2C interface. So if you use a separate microcontroller, like something small like the RP2040, for example, you can have a full graphical interface, a full OLED display, full menus. You can have memory for positions, like you can have like memory 1, 2, 3, 4, 5 to 10 to custom set your voltage range. And then you can just talk directly to the chip that does the PPS negotiation and gives you the voltage that you want. So really the circuitry that you get from these projects, like the Pico PD that we're talking about right now, is really just converting the two wires, the two power wires coming in from the USB-C into your banana plugs or your XT60 or your screw terminals. And you just get your chip talking down the same USB-C line to the charger itself to tell it how much voltage you want it to negotiate. That's it. So that box really just takes the USB-C power, gives you a better connector for electronics use or whatever for power supplying, and it does the negotiating back and forth. Everything else is UI UX. So that's it. Everything else is just taking care of your user. So whether you want to, the way you want to demand the voltage, for example, like my read-ins here, really nice. You hit volts, right? There's a button for voltage, and then it highlights one of the digits, and you can move which digit is highlighted, and then use a scroll wheel to go up and down, or you can enter with a keypad, right? So you could, in principle, design that into a front end that communicates with the PPS chip, and then it just makes the final request after. So, you would type in 6.942 volts, and then you hit enter, and then it would just communicate via I2C or SPI or whatever to the PPS chip, and it would send the request down the line. And then it's the charger, it's the actual physical charging brick that will send back that voltage. It's very interesting. In fact, when I was playing with that, I was playing with the quick charge protocol, QC protocol. And I don't know which version of the quick charge protocol, but one of the quick charge protocols allows you to request up to 20 volts on a USB-A connector. So not just C to C, USB-A. So it was very strange when I was playing with that little decoy module that I actually had to, I was actually able to pull almost 20 volts out of a USB-A connector. I don't know how much current, right? Because USB-A connectors are not that great at current. But don't forget, when we're talking about total power envelope, we're talking about volts times amps. And just because you can't pull more than let's say 2, maybe 3 amps out of USB type A, when you bring that up to 20 volts times 3 amps, that's still 60 watts. So can you imagine you can pull 60 watts out of a USB type A connector? The crazy part is with the USB type C, because it's a way better connector, you can actually pull way more current. I believe, I think the spec allows up to 10 amps now. I don't know. It's a lot. And USB type C, or the PD protocol, in fact, has provisions to go up to, I believe, 48 volts. So that is pretty insane. And I think it's 240 watts at that 48 volts. So you get 48 volts and, whatever that is, 5 amps or so. That is crazy. So maybe down the line, we're going to get even better types of, PD specs. And maybe we're going to get power supplies that can give us, high voltage. Who knows? But it's pretty exciting, the fact that you could potentially have a GAN charger, like basically a pocket size, 150 watt charger. 150 watts, maybe not like small pocket size, but like big pocket size, like back pocket. And you have that in your pocket, and you can ride your e-bike up to a wall outlet and then charge your e-bike with this, what would have been a cell phone charger a couple of years ago. Even on top of that, there are implementations where they grab the PPS signal or the PD signal, and then it feeds into a boost converter. So you don't get more current out of that. You get more voltage, but your power stays the same, right? So if you're pulling 240 watts at 48 volts, and you have to charge a, let's say, 65 volt battery with a boost converter, well, you're still going to get that 240 watts. It just won't be 5 amps. It'll be somewhere around like 4 amps. But the possibility is crazy. Like we're never going to be charging EVs with that, right? We're talking in the kilowatt range, in the hundreds of kilowatts range. But charging things like your e-bike through the same charger you could use for your cell phone and your laptop and your handheld and your drone, I think that is pretty cool. So I think it's getting a little bit late. So I think that I'm going to call it here for the podcast. I don't want to push my voice too hard. I do feel it fading a little bit towards the end of this podcast. And I have been taking breaks to take cough drops and, coffee decaf because it's getting pretty late now. So I want to thank you all for listening, but I want you to go into the description and check out the Google form that I put there. If you have any suggestions for projects that I can potentially build in one day, go ahead and add it to that list on the form. The goal is to get maybe 10 suggestions, and I will never look at the suggestions myself. The goal is I'm going to have a third party, someone, I haven't asked him, but someone like another maker would go through the list, throw out the garbage suggestions that are not doable in a day or that are trolling or not serious or whatever. And they would put all the other ones into a randomizer. They would pick one at random. And then the goal is I would do a day-long stream, 12 hours, whatever it be, 24 hours if I have to. I don't know. And I would set off to start, design, start, and complete that project, whatever project comes in randomly in a single day on a single live stream. So if you have any ideas for that, please go in the description below and fill out the Google form to have your idea added. Also, if you want to stay completely anonymous, you can stay completely anonymous, but there is a place in there to add your information so I can know who to thank for the horrible idea or great idea, whatever it may be. Also, I want you to go down in the description and make sure that you go check out all the projects I talked about today. They are the reason you have a podcast episode today, because I had stuff to talk about. So thank you so much for listening, and I will catch you on the next one.